Good morning, students. This is your RJ sir. Today we are going to discuss JEE PYE questions related to 2025 April and January. So say is based on your PYQ questions and its atomic structure. Atomic structures that is related to April and January session. April and January session. Okay. All of you concentrate and don't keep watching my channel. And without wasting our time, we are going to start the class. So first question, all of you see this. First question, according to Bohr's model of hydrogen atom, which of the following statement is incorrect is given. According to Bohr's atomic model of hydrogen atom, which of the following is correct statement that is given? Clear? So based on this, whatever options are given, you see. And incorrect is given. That's very important. It is not correct, it is incorrect. Clear? And Bohr's model. These 2 points are important. We have some idea about Bohr's model. So we can see that directly from Bohr's model question is asked. See this? Radius of third orbit 9 times 9 times larger than that of first orbit. First orbit. Clear? So that is third orbit is 9 times larger than first orbit. Second one, eighth orbit larger than fourth orbit. How many times it is? 4 times. How many times? 4 times. Next, sixth orbit larger than fourth orbit. How many times? 3 times. Okay, this is 3 times. That is 4 times. Okay, and this last one is fourth orbit. Fourth orbit is 4 times. 4 times larger than the top. Larger than the top. Second orbit. Second orbit. This is the question. Clear, student? Now we'll see the answer for this question. How to solve answer for this question. All of you concentrate, student. Yes. See, here generally in atomic structure we studied radius of the orbit is directly proportional to the principal quantum number, that is n. So we can say here r is directly proportional to n square. R is directly proportional to n square. Clear? So based on this, we can find that equation for us R directly proportional to n square. So you can see that hydrogen atom like this, your nucleus, that is the radius. Okay, so this radius is depend on your n value. If n value increases, n is equal to 1, 2, 3 like this, then radius also increases. Radius also increases. That is I written here. So n is directly proportional to r, r is directly proportional to n. So that is the 2 times, that is square of that. That is the formula. So don't forget this formula. Based on this formula, we can solve the question. Here, all of you concentrate here. The first one. We'll go for first one. What is given here? So third orbit. Third orbit means R3. N is equal to 3. Compared to first orbit. That is first orbit. R is equal to 1. So we can say two radius are given. That is first option. R3 by R1 is equal to. So how many times it is? So 9 times of third orbit to, yeah, one first orbit is 1 time. So that is 9 by 1. So answer is what? 9. So that is okay. 9 times is larger. See, according to question, they are asking incorrect. This is correct. So okay, that is right. So we'll go for next one. Next one. Second option you can see. Second option. See, in a second option, we can see that that is incorrect. No? Yeah, that is correct. In a second option, we'll go for that one. Second option. Radius of eighth orbit larger than fourth orbit. Clear? So how can you write this one? See, R8 R8 by R4 R8 by R4. Clear? So how many times it is R8 compared to R4? That is 4 times. That is nothing but n square, isn't it? So that is answer is 64. But here is that is the fourth orbit now. So that will give 64 by 60. 64 by 60. So your answer is 4. So according to question, that is also right. That is also right. We'll go for your next one. Third one. R6 by R4. Similar. 6 square by 4 square. Right? After cancellation, we'll get here 9 by 4. 9 by 4. Clear? So they are asking incorrect. What they are asking? Incorrect. Okay. So that is, you can see R4 by R2. Last one. That is, also we can go for 4 square by 2 square. So we'll get here automatically answer is 4 by the cancellation. So remaining all options are correct. Only third option is incorrect. So that is the your answer for this question. Any doubt in this question, students? If any doubt, please comment. Okay, that is the question number one. Proportional to n square. So we'll go for the second question here. For electron, 2s and 2p orbital. 2s and 2p orbital. Clear? The angular momentum of values, whatever angular momentum values are, respectively they are asking. That is for 2s orbital and 2p orbital, orbital angular momentum values they are asking. So we have a formula for this. How to calculate angular momentum, that is orbital angular momentum. How to calculate orbital angular momentum. All of you see here. So we need to see 2s and 2p orbital. Clear? So these are the options. Now we can see the solution for this question. Clear? Yeah. All of you concentrate here. Orbital angular momentum. Yeah. Orbital angular momentum formula is under root of orbital angular momentum formula is under root of L into L plus 1 into h by 2 phi. This is a simple formula for orbital angular momentum. L means azimuthal quantum number. L means what? Azimuthal quantum number. Okay, sure. Yeah. Now you can check it out here. For 2s orbital, L is equal to what? 0. Do you know that? We know orbital angular momentum for s orbital, isn't it? P orbital. Like r orbital, we can understand easy. We know that one. How to find? So L value 0. S orbital, L value 0. That is L value 0. For p orbital, L value is 2. Sorry, 1. For d orbital, L is equal to 2. And for f orbital, L is equal to 3. These are the azimuthal quantum number values. So here in our question, they are asking 2s orbital. Therefore, L value is 0. Now substitute there 0 into 0 plus 1 into h by 2 phi. We get the answer is 0. Your answer is 0. Clear? That's it. Over? Yeah. Yeah. That is here 0. How many options are there in 0? Two options are there. 3 and 4. Yeah. Check it out. Go for 2p orbital. L is equal to 1 for 2p orbital. Just now we discussed. So you can substitute here 1 into 1 into 1 plus 1 into h by 2 phi. Yeah, you can go for simplification. What will you get? Yes, root 2 into h by 2 phi. So that is your option is 4. Clear? Question number 3. All of you concentrate. The energy of an electron in first Bohr orbit of hydrogen atom given as minus 13.6 electron volts. That is about Bohr's orbit. The magnitude of energy value of electron in the first excited state of beryllium plus 3 ion is given in electron volts. Nearest integer value we require. That is numerical question. Don't forget this. Numerical question. Clear? Yeah. Come to the solution. How to calculate first excited state of beryllium plus 3 ion. See the solution. We know energy formula, that is minus 13.6 into z square by n square electron volts, where z is equal to what? Atomic number. EV means electron volts. N means principal quantum number. See, for this question, for a hydrogen atom, that is given here 13.6 electron volts, we know that. For hydrogen atom, Z is equal to 1 atomic number, and in first excited state, where N is equal to 1, clear? N is equal to 1, we know this. Therefore, you can substitute in the equation instead of Z and N value, this first excited state, we'll get here E1 is equal to, that is first orbit, minus 13.6 electron volts. But that is common for first orbit of hydrogen atom. Beryllium ion is first excited state, where atomic number is beryllium 4. So it is enter into second orbital, that is 2s orbital. You can see the electronic configuration beryllium, right? Atomic number 2. So Z is equal to 4, 1s2, 2s2, 2p 0. So in second electron, 2s electron is promoted to 2p orbital. That is N is equal to 2 we are taking. So Z is we know, N also we know. Yeah, substitute here. We can see the relation between these two, ratio of this one. That is energy of hydrogen by energy of beryllium ion. Clear? Now, energy of hydrogen, that is nothing but just now we calculated Z square by N1 square, you can take by, again we need to substitute this one, N2 square by Z square. Beryllium ion is greater than that of hydrogen, means 4 times. So we know hydrogen energy value, that is 13.6 electron volts. So generally we can take same comparison here also. Same comparison here also. Clear? Yeah. How to take this ratio? All of you concentrate here. Beryllium plus 3 ion. N value we can take here 2 now. 2 square means 4. Z value 4. 4 square is equal to what? 16. So that is here we can write 4 by 16 is equal to 1 by 4. Just comparison we can calculate. Not much calculations are there. Not required also. Just while seeing we'll get the answer. So that is the ratio. Now see the ratio of these two we can calculate here. Hydrogen is 1, beryllium is 4. Hydrogen is 1, beryllium is 4. Now you can compare here. So beryllium ion is equal to hydrogen ion into 4 times. That is, how many times? 4 times. Therefore, minus modulus, that value should be taken as positive. That is 54.4. So it is a numerical problem. Therefore, just now we discussed 54 is your answer. Nearest integer means 54 is your answer. Question number 4. See the question number 4. Which of the following, which of the following statements, which of the following statements are true? They are asking. Which of the following statements are true? They are asking. See, option 1 is given. The subsidiary quantum number L, that is not 1, L, the subsidiary quantum number L describes shape of orbital occupied by the electron. Yes, we know this. L azimuthal quantum number is describe the significance of this one, shape of orbital. For example, L is equal to 0 s orbital, that is spherical shape. Which shape it is? Spherical shape. And L is equal to 1 p orbital, dumbbell shape. Dumbbell shape. Similarly, we can discuss remaining orbital like L is equal to 2, clear? That is d orbital, dd, that is double dumbbell shape. Whereas here uh, f orbital also we can write f orbital L is equal to 3, right? That is f orbital four-fold geometry. Which four-fold geometry. Like this we have here all the L values. We can describe the shape of the orbital. That is right. First point is right. He is asking which of the following true. First one is right. Second one is given B. See the diagram is given. See that is p orbital along x-axis. This is y-axis, z-axis, and x-axis. So one probability of electron, that is electron density, around the x-axis or along the x-axis. That is correct. So what is this? Is the boundary surface diagram of orbital? Yes, that is right. So which orbital? 2px orbital. That is also right. Okay, clear. That is given. There is no confusion. Second one also right. Go for third one. What in the wave function of orbital refer to charge? Is it right? Actually, we have here. It is not a charge. We can see this diagram. All of you concentrate. Yeah, this is a wave. Electron wave is moving in this. So this is your psi. Positive upward is positive, downward is negative, middle is psi is equal to 0. Psi is equal to 0. This is wave function. This probability is wave function. So based on this, there is no charge here. This is indicate amplitude of psi, that is positive, negative, 0. So given in the question, the signs indicate charge. So that is not at all correct. So that statement is wrong. You can check it out. Such type of C very close. Now we'll go for nothing. The wave function of orbital 0 everywhere in the xy plane is giving that wave function always 0 along the xy axis. No, that is not at all possible. It's possible in a xy, yz, zx. All three axes will be possible. See in this diagram, this is node, that is psi is equal to 0. Along x axis also possible. Okay, only xy. That is also wrong. So your option is which is true. Fourth one is true. So first one, azimuthal quantum number indicate the shape of the orbital. That is right. Plus sign minus sign 2px refer to phase wave function of function, not to charge. This is not a charge. This is just only wave function. Don't forget this. And last one also given. The wave function, that is 2px orbital, 2px orbital will be 0. Question: which of the following postulates of Bohr's hydrogen atom in not atom is not in good agreement with the quantum mechanical model of atom? That is very important. Bohr's model, it is not good agreement with the quantum mechanics. Is asking that. Clear? So don't forget this. Quantum mechanical Bohr's theory, there is a good agreement, but is asking not having good agreement point in this. Which answer here? So first one, an atom in a stationary state does not emit electromagnetic radiation as long as it stays in the same state. This is first postulates of Bohr's theory. We studied so many times. Yes, whenever electron cannot jump from higher energy to lower energy, lower to higher, yes, it may not emit, may not absorb energy. That is correct only, no? Isn't it? So that statement is correct. So there is a agreement with that. That is, there is no problem at all. That point. An atom of can E1 and E2 energy levels are there. They can allow states constant energy levels. They are called here stationary states in Bohr's theory. Yes, in a Bohr's theory, first energy level, second energy level, third energy level, like so many energy levels are there. They are called stationary states. That is also right. There is no. Electron makes transition from higher energy level to lower energy level, lower energy level to higher energy level. Energy will be emitted. That is we know, isn't it? Higher energy level to lower energy means emitted, lower to higher absorption taking place. That already we know. For example, you can see E1, this is E2. Higher energy to lower energy coming, emitted energy. If lower to higher, absorb energy, that is plus E, like this. That is here emitted energy is given. That is also clear, clear point. That is no confusion there. Now come to the fourth point. Very important fourth point. The electron in an atom stationary state moves in a circular around the nucleus. Yes, this is very important point. While seeing this question, you can understand that circular path is correct. While seeing the question, this also right. You can see this option also right, but there is no wrong option in this. But this is the answer actually. This is not good agreement. This is not a circle. You can say this is a sphere or spherical. I will explain clearly with a diagrammatically. You can see all of you. Concentrate. This is your answer actually. The electron in a hydrogen atom stationary states move in a spherical path. This is correct. Not circular path. Clear? See the diagram. I will explain this diagram. Difference between circle and sphere. How circle will be there, how sphere will be there. All of you concentrate students. Very important point this is. So this is a circle. You can see left side circle, right hand side sphere. Sphere like our globe. That is the difference. So our atom like a sphere, not like a circle. Not like a circle. This is atom, not like a circle. Atom is like a sphere. So in this sphere, electrons are moving in a higher energy level to lower energy to higher like that. So this is the difference. So your option is given circle. That is wrong. That should be sphere. That should be sphere, not a circle. You got this? This is a very important point. Which one of the following about an electron occupying 1s orbital in hydrogen atom is incorrect? Is incorrect. That is question. It is also Bohr's radial. Probability of the probability of density of finding electron around the nucleus is maximum. That we may say that is a common point is we know this. They are asking incorrect, but yes, this is correct. The probability of density of finding electron around the nucleus is maximum. That is because we can say psi square. But he is asking incorrect. That is right. That is 100% correct. See this? Psi square we can write the probability of finding electron around the three-dimensional space is called psi square. Okay? The probability of finding electron around the three-dimensional space is maximum. You can find electron anywhere around the nucleus. Clear? That is we call psi square. Next one thing. The electron can be found a distance of 2a naught from the nucleus. Is it correctly of density is maximum is psi square? That is okay. And second one, electron distance we can find any from anywhere. That is also right. That is also right. We can exist infinity nucleus from infinity to anywhere we can find. That is also right point. Now you can see third one. The 1s orbital is spherically symmetrical. Yeah, just now we discussed all these things. Spherically, the total energy of an electron is maximum when it is a distance of a naught from the nucleus. Particularly is giving this. When it is maximum, when distance is compulsory a naught. No, that is not correct. It should be, so this is the incorrect statement. Incorrect statement. Incorrect statement. Clear students? Clear? So energy of electron is maximum at any distance from the nucleus. Okay? Any distance from the nucleus, not from the particularly a naught. Next question. See the question. Consider the ground state of chromium atom, that is atomic number 24 we know. How many electrons are with azimuthal quantum number, that is L not 1, L is equal to 1, L is equal to 2, L is equal to 1, L is equal to 2 respectively. We are asking azimuthal quantum number values from the chromium. We know this chromium atomic number 24 is given. Electronic configuration we can write. This is electronic configuration of chromium. Where you can see L value. L is equal to p orbital. How many p orbitals are there? 2p6, 3p6, both are true. So where L value 1, L value 1. How many L value 2? L value 2 means d orbital. How many d orbitals? 1 d orbital. Now you check it out. L is equal to 1 means p orbital. Similarly, electrons having d orbital. L is equal to 2, d5. Yeah, so that's compulsory. We have to know electronic configuration. So our option is what? 3. 12, 5 or 12 and 5. That is your answer. We'll go for next question. See this? That is option 3. Read the questions. Correct statements for the An element with atomic number 9. 9 means fluorine.
Atomic number
Is
9 is
fluorine. There are 5 electrons which ms magnetic value is plus half, whereas plus half means upward direction, that is positive sign, and 4 electrons for this which has minus half, that is nothing but downward direction, electron positions downward direction. We can see that one. Yes, this is as it is. We can write the electronic configuration. We can find this easy, clear, upward direction and downward direction. Okay, students. So see the option, next option. There is only one electron in pz orbital. pz orbital contain only one electron is given. We'll go for the explanation now. Write the electronic configuration: 1s2, 2s2, 2p5. 5 electrons. See this? 5 electrons can be upward up spin, that is ms is equal plus 1. Yeah, right or not? Yes, 1, 2, 3, 4, 5. Correct. Question also given correct. Yes, that is right. Similarly, 4 electrons can be down spin. Yes, that is also correct. 1, 2, 3, 4. Yes, that is also right. Clear. This much of easy. 4 electron. Next one, B. Uh, any one of P, Z, E, Y, P, X, any one may be contain unpaired electron. Not only particularly in this, only that orbital. It may be contain any orbital. Not only PZ, we can see in that is not at all correct. See, Px this is, Py this is, Pz. Yeah, any one may be contain electron. We can fill any one because these all are degenerate orbitals. All are equal. All are equal. Degenerate orbital. So therefore, we may not say only in one electron containing pz orbital. Maybe it is 2px, 2py. Also possible. So that is very, very important. The point only will give the answer for this question. Remaining all are easy. Next one, you can see here. You can see here. Anyone can be electrons may be contained. That is not only pz. Clear, sir? That's clear. Only one electron contained in pz, not only pz, even in s, px, py also possible. But first one and second one, that is we can understand. Next we'll go for here. Third one. See, the last electron goes to n is equal to 1. Is it right? You can see, check it out. Last electron, that is 2p5. Yes. N is equal to 2, L is equal to p orbital 1. That is also right. That is also right. Clear? Now, we'll go for D. The sum of angular nodes of all the atomic orbitals is 1. Okay. Now, we'll discuss, this is very important for us. What are nodes, angular nodes, radial nodes, all these things with clear explanation. All of you concentrate. Here, what is this? Angular node, radial nodes, nodes, planes, all these things. Angular nodes are equal to L. That is the formula. And the nodal planes equal to L. Both are L. Angular nodes, nodal planes, both are equal. That is equal to L. L is equal to 1. Angular nodes are 1. Nodal planes also 1. Clear? Similarly, angular nodes for the S orbital is 0 because it is 0, and for P orbital is 1. So here is asking that a question. You can see this. Total all atomic orbitals we are mixing. Answer is 1. You can see how many atomic orbitals? 1s2, 2s2, 2p5. But what about p orbital? We have here 2px, 2py, and 2pz. Isn't it? 3 orbitals are there. So you can add these 3 orbitals values. Then we will get the answer. We will get 3 answers. But is given all atomic orbitals angular nodes equal to 1. That is wrong. This is equal to what? 3. Only s is 0. But remaining p orbital will be 3. So your that given option is wrong. Okay, clear? Total is 3. Given option is wrong. See this? 1 is given. But our answer is 3. Clear? So now check it out, which is correct option. Clear, students? Now I will explain one more thing here. All of you concentrate. Radial nodes. Come to this point. Radial nodes. See, radial nodes are equal to the simple formula you have to remind is equal to n minus L minus 1. What is the formula? N minus L minus 1. N is equal to principal quantum number, L is equal to azimuthal quantum number, 1 is 1. You can substitute here, we will get the answer for radial nodes. Next time, better luck next time, maybe question based on radial nodes. Okay, come to the next question, question number 9. Okay, the extra stability unpaired electron, that is meaning of why it is field more stable than incompletely filled. We discuss now generally. Atomic orbital, half filled and full filled orbital more stable. But is asking extra stability for half filled. Why? Why will you get here extra stability for half filled is asking. You can get here, for example, 3D orbital, one is all are having 5 unpaired electrons. These are having symmetrical distribution. Okay, and smaller Coulombic repulsion energies, less energies Coulombic repulsions. Okay, and these are here we have larger exchange of energies. Okay, and one more here, relatively smaller shielding electrons by one and other, relatively less shielding electrons, shielding of electron one another. So these statements, how many are correct? We can check it out here. Presence of electrons in a same spin non-degenerate orbital, that is wrong. So C is wrong. So where C is not there, that will be your answer. So where A is there, that is also your answer. Check it out here, option symmetrical distribution. Yes, smaller Coulombic forces, that is also right. So large energy exchange, that is also right. Relatively smaller shielding effect electron by one another, that is also right. So our option is A, B, D, E. C only wrong. Option is A, B, D and E, but not C. Clear? That is your answer. That is our answer. Yeah. That is again you can see extra stability, symmetrical distribution, large exchange energy, smaller cooling process, smaller shielding of electron by one another. This is very important questions. This is here today's class, students. Please subscribe my channel. I will post next one other topic. Thank you very much. Thank you for watching my channel. Thank you.